This is Amy. Welcome to my math class. Today we are going to look at graphs of factorized cubic functions. Let's get started. First, let's look at this cubic function, which is in the factorized form, and there are three distinct factors, which are x minus 1, x plus 2, and x plus 1. We will use the sign diagram to get the basic information of the function. First, get the equation. Then use the non-factor theorem. Let each factor be 0, obtain the solutions to this equation. Then we will have x equals 1, negative 2, and negative 1. Then place these three values on the number plane in the accurate order. These three values divide the number line into 4 sections. First, we confirm the sign of the first section, and here we can select value x equals 2 to determine the sign of the first section. And when x equals 2, the first bracket will become 2 minus 1, which is 1, and second bracket will become 2 plus 2, which is 4, and the third one is 2 plus 1, which is 3. Then the product is positive. Therefore, the first section is positive, second section will be negative, third one positive, fourth one negative. To the right of number 1 is positive, and then we start from positive section, and then it becomes 0 at x equals 1. Then it becomes negative. At some point, it turns around and becomes 0 again at x equals negative 1. After that, it becomes positive, but at some point, it turns around and becomes 0 at x equals negative 2. Then it becomes negative. So this is the graph of cubic function with 3 distinct factors. Then we are going to conclude what are the features of this type of graph. For the cubic of the form of 3 distinct factors, we are going to restrict the coefficient of x cubed by positive to make the situation simpler. And then, based on the graph, we are going to conclude the shape. It is climbing up. The main trend goes up, but there are 2 hills. Then we will show the shape in this way, from negative infinity to positive infinity. But in this case, we call it climbing up double hills. Then the second feature, we can see there are 2 flat points. We call them 2 turning points. The exact coordinates will be learned in the future. And then second thing is that the turning point is not symmetrically located between the x-intercepts. The third key feature we have to know the y-intercept and x-intercept. For y-intercept, we just let x be 0. For x-intercept, we let y equal 0, but it is in the factorized form. We can get the x-intercepts directly, which are alpha, beta, and gamma. For the shape like this, it's like climbing up double hills. We can see there are 3 x-intercepts, but we may have different numbers of x-intercepts. For example, in this situation, there is only 1 x-intercept, which is here. But the x-axis, if just pass through one of the turning point, then in this case, there are 2 x-intercepts. We are going to investigate what will be the form of the function if there are 2 x-intercepts, or if there is only 1 x-intercept. When there are 2 x-intercepts, here we have the x-intercept beta. To the right of beta, the y value is positive, and to the left it is negative. And then we can create a vector which is x minus beta. Then we look at another factor, alpha. So for this one, to the left and right of alpha, the y values are all negative. Only at alpha, the y value is 0. then it means around alpha, the function does not change the sign. It means we are going to use x minus alpha, but when we square it, then the graph will not change size around alpha. Therefore, this graph we can express in this form with one factor repeated. Now let's look at the case for this shape of climbing up double hills. What will be the form of the function if there is only one x-intercept? First, by observing the graph to the left and right of alpha, the signs of y are different. To the right of alpha, y values are all positive. To the left of alpha, the y values are negative. In this case, we can create the factor x minus alpha because the graph crosses the x-axis. And then another factor should be a quadratic expression, and we have ax squared plus bx plus c. For this one, we can see the graph does not have any other x-intercepts. It means for this factor, there are no real solutions. Therefore, the discriminant b squared minus 4ac should be less than 0. For the shape of climbing up double hills, we always have two turning points for the graph, and then if there are three distinct x-intercepts, and then the form will be like this. The case with two x-intercepts, then the expression will be like this. For the repeated factor, it means the graph touches the x-axis at this point. The case with only one x-intercept, then we can get one factor, linear factor first, and the quadratic factor, the discriminant must be less than 0. It means the graph cuts the x-axis only at x equals alpha. Now let's look at example 1. For part A, there are three distinct linear factors, and we are going to find the x-intercepts first, which are -3, 1, and 3. Then these three x-intercepts divides the x-axis into 4 sections. Then we are going to use the sign diagram to determine the sign first. Then to the right of 3, we can use a value, for example, select x equals 4 to determine the sign of y. So 4 plus 3 we have 7, and 4 minus 1 we have 3, 4 minus 2 we have 2. Then the result is positive. It means the first section is positive, and second section negative, third section positive, fourth section negative. After that, we are going to sketch the diagram. So to the right of number 3 is positive, and then it is 0 at 3, then turn around at some point, becomes 0 again at x equals 0. Then becomes negative, and then come down, and then move down. And here we can see there are 2 turning points, but we are not going to find the x coordinates now. And then you have to label the y-intercept. Just let x be 0, get the value. I will skip this one now. Let's look at part B. So the coefficient of x cubed is still positive, then the graph should be climb up double hills. We have one repeated factor, which is x, then this one we label the x-intercept is 0, and for x minus 1 we will get x-intercept 1. The sign of the graph will be determined only by this factor x minus 1. And to the right of 1 it is positive, and to the left of 1 it is negative. Therefore, we are going to use the sign, and the graph cuts the x-axis at 1, and then at some point it becomes 0 at x equals 0, but it does not change sign. It is still be negative underneath the x-axis. Here we can see there are 2 turning points. For question C and D, we can see the coefficient of x cubed is negative. Therefore, the original graph will be refracted in the x-axis. Then the shape will become climbing down double hills. and this one the same, climbing down double hills. Then we need to determine the x-intercepts. For part C, there is a repeated term, and it tells us the x value is 2, and another factor, a linear factor, the x value, x-intercept will be -1/2. Then the sign will be mainly determined by this term and the coefficient. To the right of -1/2, so their values are mainly positive except the value at x equal 2. Then we are going to select one value to determine. For example, we are going to select x equals 0. Then the y value will become negative. Then 0 minus 2 all squared times 1. And this value we will have -2 squared, it is +4, then times 1. The product finally is negative. Therefore, to the right of -1/2, the y values are negative, but to the left, it will be positive. Then we are going to sketch the graph, and the graph will cross the x-intercept at x equal -1/2. Therefore, it will go down and become 0 at x equals -1/2. Then it keeps moving down, but at some point it goes up and touches the x-axis at x equals 2. Then the graph is basically like this. For the y-intercept, then we are going to calculate, let x be 0, and the same, I'm going to skip this step. Then for question D, we have already known the graph is like climbing down double hills, and it has one x-intercept, x equals 1, and for the quadratic factor, we have to check the discriminant, which is b squared minus 4ac. For this question, b is 4, a is 1. For this question, a is 1, b is 4, and c is 5. Substitute all these values into the formula. We will have 16 minus 20, which is -4, which is less than 0. And it means no any other real solutions of x. Then the sign of y values will be mainly determined by -x minus 1. We can select a point to the right of number 1 to determine the sign. For example, we can select x equals 2. Then the y value, -2 minus 1, will be negative. Therefore, this part, all the values are negative. To the right, it is positive. Then the graph can be like this. Here goes up and then come down and cross the x-intercept at x equals 1. But it's possible that the graph is like this. It cuts the x-axis at x equals 1, and then it goes down, and at some point it goes up, and at some point it goes down as well. Now, how can we determine whether case 1 or case 2 is the accurate one? In order to do that, we will need the information of the turning points. If we can determine all the turning points are to the left of number 1, then we will need case 1, but we haven't learned the knowledge of differentiation. At this stage, we can only use the technology to determine case 1 is the accurate graph and case 2 is not. The graph obtained by using decimals, it's like this. So both turning points are to the left of number 1. That's all for today's content. Thank you very much for watching. I will see you next time. Bye.